Hey, what's going on, guys? Welcome back to the channel. Today we got a brand new project we're starting. We're gonna be building an elevator lift that goes from the shop floor up to the attic. I've been gathering lots of parts and pieces and been kind of thinking this project over for a while, and it's gonna be a little bit different than probably some other ones you've seen online. It's gonna have some similarities, but I think this one's gonna be pretty well built and pretty cool. So let's get going. So let me show you the parts that I got for this thing, and I'll kind of explain how it's all going to work. All right, so to supply the power for the actual lift, we're using a Vevor, the 2,200 pound, 110 volt hoist motor that they have. We're actually going to be removing the hoist cable and drum off of here. We'll be installing a 18 tooth gear to that. Be using some chain. We've got some pillow block bearings. Got some trolleys for our unistrut. This is kind of where things get a little bit different than everything else I've seen online. Normally guys will just build a platform, they'll hook the cable to it. It might be riding up on some strut, or it might just be hanging from the ceiling coming down. And this one is gonna be mounted the strut on the walls. The platform's actually gonna fold down off of the walls, like kind of like a lift gate on a truck. So I don't want the platform just to sit here and block off my window. It's actually gonna be able to go up these struts, and when it gets right above this window, it's gonna fold flat to the wall. The way I've been thinking of this, and the way I think I'm going to do it, is I'm going to use that hoist motor to power. I have this 1-inch shaft here that's solid and is keyed. I got a 40 tooth gear here, so we're going to reduce the speed a little bit. We're going to go from 18 tooth to 40 tooth. And it's going to act kind of like how a garage door acts, so it's going to be able to wind both sides at the same time. And like I said, since it's going into a grooved drum, the cables will wind nice and neat, and it will be able to stay perfectly level. Even if there's more weight on one side than the other, both sides of the shafts are going to turn at the same exact speed, so it's always going to stay level. We're going to use a set of pillow block bearings. We'll have one at each end. We'll probably have a few in the center for support. We got the gear here that's going to go on the shaft, so the gear is keyed as well. It's got a keyway in it that matches the shaft. So we got some key stock here to do that. I did find these really nice heavy-duty trolleys. These were off Amazon, and they're super robust and heavy, and like 3/8 plate they're all made out of, so these are gonna be really nice. The hoist itself uses a remote control, which would be nice to be able to operate it without having to stand by the wall or button or something like that. Brackets, these are gonna get welded onto the side of the strut so we can bolt it to the wall and to the floor. I don't have the actual platform. I'm gonna weld up out of some 1.5-inch tube steel, some square tubing. And then I'll put a piece of like 3/4 inch plywood on it. I think it's gonna be a pretty fun project. I've been looking forward to this for a while. So the first thing that we're gonna have to do here is, if you look, our strut's gonna have to go up past this header all the way up to basically the top of the window where the bar is gonna be. In order for that to happen, I need to bring the strut out so it's flush, so it sits on top of that header. So what I'm gonna do is, I got 2x6 here. I'm gonna have to notch out my little trim board here, so it goes on the wall all the way down to the floor. And my bottom, I did like a 5/4 board at the bottom here to keep the OSB off the concrete. This sticks out about 3/4 of an inch here. So I made a 3/4 inch notch in the board here, and I put a little taper on the bottom. And this board's actually gonna be about 1 inch off the floor. I didn't wanna have non-treated lumber touching the bare concrete. But I did want this to be able to put pressure on the grade board that's behind here. So what this is going to do is distribute the load across all of the purlins in the wall. It'll give us something to fasten our strut to. And I can't just bolt through the back of the strut, because just so you can see, it's going to hit that bolt. So I have to attach to the side. I'm going to weld them to it. It's going to give us our spacing off the wall. First step will be getting these mounted. I'm going to have to get that trim board notched out, and I'll get them screwed in place, and then we can figure out the depth of those angle brackets we got to put on the angle iron there. We're going to be using some 4.5-inch timber lock by 1/4 inch structural screws. So these are the equivalent to like a 3/8 lag bolt. And what we're going to do is, I marked out the center of each wall girt that's in the wall here. I'm going to put one screw right in the center of this 2x6, And then when we come back with the strut, it's going to have the double angle iron on each side, and it's going to get 2 more screws on either side of it. So there'll be 3 screws into each of the wall girts going up, basically every 2 feet. I did just go look outside to make sure I'm not running them through the outside of the building, which they're not. So I just wanted to make sure before I went and put a dozen of them through the wall, because that would have been bad. Little Dachi. Well, I'm an idiot. See how big this gap is? 8 inches or so. 3 inches, not even. I was supposed to put the board on this side of the laser line. Laser line's here. I should have moved it over. Now I gotta take it down, move it over. Don't tell anybody that we made this mistake. That's the window from down below that we're looking at. And originally, I framed that because I thought I was going to put a ceiling on the other side of that and just have the light reflect down into there. But now that I'm doing this, I'm going to end up taking those out. So we're going to have to get some of these out of the way. I'm probably going to put some planking across from here to the window or something so I can work up here easier. Yeah, this is a decent space up here. I do have the floor down. It is only a 512 pitch, so it's not like I have a ton of headroom. I can almost stand up in the middle. It's a full 8 foot wide there. This area is like 11 by 16, this space here. Where's an elevator at when you need it? I'm out of shape. So that's a lot better than trying to work off a ladder. So I think my plan is I'm going to get this 2x4 out of here, and I'm going to replace it with a 2x12, basically the same height. You know, as the hoist is pulling up on this, all the loads will be pulling down on this header that we put across here. So we'll have it sit on the top plate of the walls on the ends, and just kind of lock it all together, tie it all together, scrape off the foam, and see where we can get the 2x12 mounted up. It may look a little funny that these stop short, but the header's actually here, and it's a double header, and it's all the way to the outside. It's actually, and I left like this 2-inch gap here on the inside, so it has to be insulated. If it's just all solid lumber to the inside, then you got no thermal break from the outside there. So that was kind of the reason for it.
Hi, everybody.
Good morning, guys. So last night we got kind of late, so I wrapped things up. Me and Tommy this morning, we went to his favorite store. We went to Menards. We picked up an LVL. After thinking about it, I'd rather it go through an LVL just because there's going to be a lot of twisting, pulling force on it. And I figured an LVL might be some cheap insurance to have up there. So he still doesn't believe me that we're building an elevator. What do you think?
Now I do.
Now you do. Thank you, sir. Okay, so these are gonna go in behind here. They're gonna get anchored into this post. These are gonna get anchored into here. It's gonna sit on that. It's gonna tie all this end together. It's also gonna keep this from rolling. So I just gotta clear out some of that foam on that post there. All right, I think it looks pretty good, nice and solid. Plus it's sitting on the 2x6, that sits down on the header. It's all tied into the post. There's a 6x6 post back here. So everything's locked together, screwed together. We're good, we're not going nowhere. Okay, so we're gonna get our unistrut joined together. I'm gonna end up welding these together. So I'm gonna use this as a straight edge. So make sure that they're in line with each other good. We're gonna clamp it. So we need a total height of 203 inches. That's gonna go from the floor to the bottom of that LVL we just put in there. So basically these are gonna die into the bottom of the LVL. So I'm just gonna get these kind of clamped in place just to hold them so it doesn't move around as I tack them. Basically I just wanna make sure that it's all straight and parallel. Okay. All right, let's loosen a little bit more. Okay, now squeeze the handle. I want to make sure it's as smooth of a transition as possible. Anytime you're welding galvanized material, that white smoke you see coming off of there is not good for you. Make you real sick as far as like symptoms. You feel like you have the flu if you breathe in too much of it. So you just gotta be careful. This is such a little amount of welding here, I'm not too worried about it, but normally if you're welding any type of galvanized, you wanna get some ventilation and wear a mask. All right, so we got it joined together, got it welded. I know it's probably not the prettiest weld, but I kept the heat purposely low on it because I didn't want it to have too much penetration and create a bump on the inside that it wouldn't be able to grind. So I kept the amperage down quite a bit to basically just sit on there and fuse them together, but without having anything bulging out on the interior. So it's a nice smooth transition there. That's gonna get hung up, weld it all the way around. It looks good. So love this little guy here. This little grinder thing, sweet. Especially when you're not trying to take a lot of material off, get a lot of finesse with it. And I mean, it's got the same RPM like a die grinder, pneumatic one would have. So it works really good. So now we got it welded up. We can cut it to length, and then we'll see where we need to weld our brackets on to hold it off the wall. All right, so you can see pretty much how this is going to go. It's going to sit on the main header of the shop there, go all the way up to the bottom of the new header that we put in, that LVL. And then we got to hold that distance off the wall, which is about 2 inches, all the way down to this 2x6 that we put in, all the way to the floor. So every place we put in those big timber lock screws into the wall girts in the wall, we're going to take 2 of these angle brackets, and we're gonna go ahead and stitch these on here, weld them on, and there'll be 1 on each side, and that'll get bolted straight through through this 2x6 and into the 2x4 wall girts that are in there. The only thing I don't like is these are longer than they stick out past the unistrut by about a ½ inch, so I'm probably gonna have to trim all these down, but that's what hangs over. So we're gonna cut all these, and it should look a little neater when it's all together. So what I did was I cut some blocks that are exactly the 2 inches that I need this to be held off of the wall there for the brackets. So I'm gonna go through and put basically these all the way down. Just make sure this is held flat and just put them right on there like that. Welding clamp on here and just weld them right in. So this is going to be the bottom that goes to the concrete here. And what I'm going to use is this is a unistrut bracket. I'm going to put it on the back side because we got room between this and the wall. Just weld this on here. So what I decided for the top, this is the back. Up at the top, this is going to die into that header we put up there. What I'm thinking is I can put a plate on the back like this. I'll weld it on here, and then I can through bolt it through the header, through this plate. And this is on the back side because all the force on this wall is going to try to be pulling it off the top. So instead of trying to screw something up into the end grain of this where it might, delaminate or separate, if it's behind it, I mean, theoretically, I don't even need bolts in it to keep it from coming off the wall. You want the bolts there to keep it from shifting right or left. All right, kind of went in just like I thought it would, which is good. One thing I just thought of while I was putting this up there is I need to put those trolleys in now. I gotta slide it out and put them in there because once I anchor this in, it's trapped top and bottom, and I can't get those out. I'm probably gonna have to mark out where this hole is, slide it out of the way, drill it, because I don't think I'm gonna be able to get my hammer drill in here, or at least not straight. I'm gonna drive them in, I'm gonna leave them a little loose, and then I'll get it lined up and crank them down. This is where a laser really comes in handy. If you had to do this with a level, and trying to put a level on here and hold it and work your way up, by the time you got to the top, I'm sure it wouldn't be perfect. It did grab good, so that's good. Beautiful. So these we're going to use to go through the LVL into that plate we have going up the back of the strut through those two holes. And I just happened to find these in my garage. They're much longer than we need. So I'm going to cut them down, and you need room for the nut and the washer. So I think if we cut them down to 3 inches, we'll have plenty of thread left for the nut and the washer. So one little trick, if you guys ever have to cut down any fasteners, go ahead and put a nut on them lower than where you're cutting. And that way, once you make your cut, you can deburr the end of it, file it, or whatever you're going to do. Put a slight taper on it. But that way, when you take the nut off, it kind of just chases and cleans up those threads, because sometimes you'll get one of the threads will fold over on itself when you file it or grind it off like that, and it's really hard to get it started, that very first thread. So by doing that, it just makes it super easy to go ahead and get them rethreaded. It's not... All right, beautiful. Famous last words of any man is, that ain't going nowhere. So I think this thing is more than adequate. I'll have you look down. It's perfectly straight. I don't know if you can see the laser, but it's dead nut straight that way and this way. So very happy on how this is coming out so far. What I'll do is I'll go ahead and build the other one and get that installed. I probably won't film it just because it's going to be exactly what you just saw here. And then we can move on to the hoisting system and figure out how we're going to get all that mounted. But so far, so good. Thing looks good. I'm happy I went with the LVL. I just like LVLs. If I had enough money and I could build a new house, I would do every floor joist and every rafter and every single piece of the house would be made out of an LVL just because they're so straight and strong. I just love them. But they're expensive. This was a 12-foot, 11 7/8 by 1 3/4, $77 or something like that. Compared to a 12-foot 2x12 is probably 18. So significantly more expensive for sure. But sometimes you need them. All right, guys. So I went and had some dinner and came back out. I did get the other rail all welded up and installed, perfectly straight, just like the other one. I don't know if you can see the laser or not. The shaft that's going to go up there with the cable drums, my pillow block bearings, my gear, chain, all that good stuff. I'm probably going to either get some 2-inch square tubing, like steel tubing, and make some standoffs basically like this, but larger, just to get that a little further off of the block there. So I'm probably going to just call it a night tonight. Tomorrow we'll be back at it. This morning I went and picked up some steel, got some 1.5 by 1.5 1/8-inch walled steel tubing, and I got a chunk of 2x2. I'm going to use that for the spacers for the pillow block bearings that we were talking about earlier on the shaft there. But before I mount that up there, I think now that I have the steel, I'm going to jump to building the actual platform and the hinge mechanism, because this is going to be the platform. This board I have on the floor here represents where the end of the attic actually ends there. So what I would like to happen is when this is down, this is the platform that you put your materials on, or totes, whatever I'm going to put on here to go up, that when it goes up, it basically comes out flush, so there's not a big gap or anything that I have to step over onto the attic space. It'll come up and you'll have just a clean transition, maybe a half-inch gap or something like that. So kind of what I have laid out here at the moment is this is the upper trolley on both sides, and the lower trolleys are down here. So these trolleys, the bearings are lower, the lower wheel is lower than where the mounting flange is on the bracket. So this bottom one doesn't go tight to the ground. So what I'm thinking of doing is when I build the frame for the base here, the platform, there'll be a tube that comes across. I'm going to miter it and have it come up. And what I'll do is I'll weld a plate on here with a nut on the inside, and we'll be able to bolt through here, and that will be the pivot point. So once this is all connected together, and I want to fold this up out of the way, this will go up like that and go up against the wall. And then what will happen is from the ends of this tube out to this platform, this would just be made up of probably like a 5/16 chain of some sort, or maybe a cable or something like that, so that when it folds down, it's like a tailgate. It folds down, and then you got on each side, you'll have your cables or chains that keep it level where it needs to go, but that allows it to fold up out of the way. I think what I'm going to do is get some more dimensions, measurements, and then I'll start cutting up some steel, let you guys see how it all kind of comes together. What I can actually do is just do them both at the same time. I'll at least get them all tacked together. At least I know both of them will match exactly. I mean, you can see this cut slightly off on this one, but I mean, that'll get welded up. At least since they're both touching, they both match. I'll just do a few tacks on the corners, then I can separate them and fully weld them up. And I also swapped out all the lenses in my helmet, and it's amazing how much clearer it is when you got fresh lenses in there. When I was welding the other stuff up, I couldn't even see half the time when I was welding. Turned out pretty good. So that's parallel with the track going up the wall. And what that did was locate where these are in relationship to the tube that they're going to get the pivot bolt that goes through. So these are some unistrut square washers that are going to go get welded on the ends of these tubes. I'm going to weld a big 1/2-inch nut on the back side of this, and that way I can pass a bolt through here and thread it into that nut, and that'll create our pivot for us. And I did leave a little room where I can put like a nylon washer between these two, like an 1/8-inch washer, so help it pivot. But I was trying to figure out an easy way to transfer the center point where I got to drill the hole to the center of this tube, and then I realized these strut washers have magnets built into them. I didn't even realize that when I bought it. And what I can do is just kind of hold it on this tube, and that's exactly where I got to drill my hole. Tell you what, these Harbor Freight step bits, they're like the upgraded version of, like they have their normal gold ones. These are like their, I don't know if they're cobalt or whatever titanium they are, but they cut great. I just cut some chunks of the tube, just 1.5 inches by 1.5 inches, just to make some end caps here. Looks good. I'll just grind it up a little bit, make it look pretty. All right, so this is the tube that we got to put the end caps with the nuts on the inside. So we're gonna weld the nut on the inside of that plate like that, and then weld the plate on here with the nut on the inside so that the bolt can thread into the end of it. So if you're ever welding a nut onto something, sometimes it can deform the threads on the inside if it gets too hot. But if you take a bolt and you put it in there, coat the bolts in some spatter spray, anti-spatter spray, help the bolt from getting fused into the nut, and then when you take the bolt back out, it helps kind of clean up the threads again as you take it out of there. Now what we need to do is mark out our holes through this tube. We got to drill this tube so it can bolt to this trolley here. So instead of drilling all the way through and trying to make sure my bit's perfectly straight, I'm just going to mark the same holes out on the other side. I just transferred them right around, and I'll mark them out on this side and drill from this way, and then run the bit all the way through both. That way we know we're going to be straight. Sometimes you go in there and you hit the seam that's in the pipe and your bit wants to walk, come out sideways. We don't want that. So by doing it that way, the holes line up real nice. Bolt drops right in, nice and straight. And I'm gonna put these, I got these thin stainless washers. That's gonna replicate probably the little nylon washer I'm gonna put between here. And we'll tack everything in place. Okay, we should be able to test our pivot. So that's how it'll be when it's folded up. Okay, so we got the upper tube temporarily bolted in place. We got the end caps welded on with the nut captured inside there so we can bolt the limit strap on the end of it, tailgate strap, whatever you want to call it. Okay, should fit now. Mark where I got to cut this one on an angle. See how that one's on an angle like that? It's like a diagonal brace. So I got some 5/16 chain here, and it doesn't really need to be this heavy duty of chain, but this is what fits a 1/2-inch bolt really well, and you can pivot on there, and the links are large enough for it. So again, these are just some temporary hardware because I don't have the actual bolts I'm going to use. We're going to have to cut this link here. That's the chains. That link length is pretty much perfect, and it should be able to fold right up.
Hey, you have to stay holding it.
Huh? Well, I'm going to make a latch for it once the plywood's on here. See, that feels good. Right now it's off the ground. I got some blocks under the back beam of this right now, so it's holding it up off the ground like 6 inches.
6 inches.
And I don't have all the bolts in either. There's only a couple fasteners hand tightened in there. Works out well. Watch out, buddy. And then when it goes to fold up, the chain goes out of the way real easy. And once the 3/4 inch plywood is on here, it'll stop basically like that, which is like perfectly vertical, plumb to the wall, and it tucks out of the way pretty well. So I did the math on the weight of all the steel. 52 feet of 1.5-inch tubing, the 1/8 inch wall, 2¼ pounds per foot, so it's 117 pounds. There's going to be a sheet of 3/4 inch or OSB, the subfloor, a 4x8 sheet, but a 4x8 sheet of that's like 72 pounds. So call it 70 pounds plus 117. So we're 187 pounds total on here, which is good. That's about right where I was thinking it was going to be, right around 200 pounds worth of materials for the actual hoist part, and we're a little bit under that, so that's good.
We're pretty good.
So I think we're gonna call it a night tonight. We're ready to go inside. It's like 20 after 9,
You want
Saturday
to?
night, and tomorrow
It's church.
we'll probably go to church and then come back out here and try to get this thing working tomorrow.
I'm
Here, I'll
gonna
throw.
wow.
Give me the football. We'll throw it to you, see if you can catch it. It's your big moment. Nice one. All right. Say goodnight. Say see you tomorrow.
See you tomorrow.
Hey, morning, guys. So I just got back from the farm store. Went to Family Farm and Home and got a bunch of hardware, nuts, bolts, washers, lock washers. And usually if I got to buy any type of non-specialty fasteners, I'll get them from there because they sell them by the pound. And like the grade 5 stuff's only like, I don't know, $3 something a pound, $3.99 a pound. The grade 8 stuff's like 6 something a pound. So it's a whole lot cheaper than buying it by the bolt like at a hardware store, you know, when they charge you $3 for one bolt. Definitely didn't need grade 8 hardware for this, but everything I'm doing on, I'm kind of doing above and beyond what it needs to be just because it is technically like overhead lifting. So even all the components to the lifting, the hoisting part are all gonna be approved for overhead lifting. So the cable's approved for overhead lifting. The cable ends that are gonna be the adjustable ends that connect to the top tube there on the hoist are gonna be approved for overhead lifting. The cable drums that the cable actually rolls on, that's designed for a garage door, which technically is overhead lifting. If you think about it, it's probably one of the things that's approved that you can walk underneath while it's elevated. Most things, even if it's approved for overhead lifting, you're not supposed to go underneath. So those are designed for 750 pounds a piece. The cable that's on them is 840 or 850 pounds per side. The hoist itself is approved for overhead lifting. It's not like a winch for, like the front of a truck or four-wheeler. It's actually a hoist. Like I said, I'm trying to overbuild. I'm trying to make it to where it is safe. I mean, for a little bit extra money, I think I'd rather build it the right way than save a couple $100 and cheap out on some cable or some end fittings. I don't have it here yet, but I am going to be installing a limit switch system for this. So we'll be able to set the upper and lower limit. And for 2 reasons. One, obviously, we don't want to run it up too high, crash it in the top of the tracks, and then overload the hoist and break a cable or something like that. I don't want it to go too low and hit the floor and slack the cables to where they bird's nest or get loose on the drums up top. I want tension on them at all the time. So like I said, you can build it exactly the way I'm doing it, or there's plenty of places where you could cut down on cost and still get kind of the same result. I like things that just work when the way they're supposed to work. You can build anything that works, and if you're the guy that built it and you got to do a certain thing to make something work a certain way, do something so something bad doesn't happen, yeah, that's fine. But on something like this, my thought was make it as safe as possible, and hopefully that's the result we get. So these are what we're gonna make for all the bearing block locations, the 2-inch spacer to hold it off of the LVL that's up there. So obviously the 45 isn't necessary, just it kind of makes it look better, I think, in my opinion, than just a square chunk of steel sitting up there. So I gotta make up 6 of these. So I just did a test one to make sure it's how I want it. We'll get 6 more of these cut. Once you cut 145, you can just use that end, so just got to keep cutting them back and forth. We'll get 6 of those cut out, and then we'll have to mark out our holes and drill through them for the bolts to go through them. So I got all the holes drilled. I put a 9/16 hole in there for the 1/2-inch bolts. And I also put a little, 5/16 or something hole for like a screw or a lag, because I figured I can get these all mounted in place first and then mount the bar and blocks to it. Because I got to put all that up at one time. So if I got to put these up plus that up all at once, it's going to get pretty awkward. So I can pre-mount all these in place, get that up, slip the bolts through, and we'll be in good shape. I want to show you guys, I never used this stuff before. I mean, I've used all kinds of cutting fluids and things for when you're drilling or tapping. But I was at Lowe's the other day, and they had the stuff made by Spider, and it's called Mock Blue Goo. And it's like a goopy paste almost that you put on your, where you're drilling your hole. But it works great. It doesn't stink. Like some of the tapping fluids and cutting fluids I use, they just smell so bad when they get hot when you're drilling. It doesn't stink. It wipes off real easy. I don't know if it's water-based or what it is, but yeah, water-based, non-toxic. And it doesn't drip. It's real gooey. So like you put a glob there and it just stays right next to the bit. It's not all running down your parts and putting oil all over the place. So if you guys do any drilling, I haven't tried it for tapping or cutting metal, but like I said, it did work really, really good. Put one bolt through here. got room on the back side to get a nut and washer back there, which is good. So with these cable drums, there's a right and a left, and this is where the cable starts, and then it winds up. So when it's all the way up, the cable fills this whole spool basically. So these are for an 18-foot tall overhead garage door, commercial door, and our from floor to shaft, we're basically like 17'6", so it's almost perfect where it's at. And what that allows is once it's all the way to the floor, there should still be at least like 2 full wraps of cable on the drum. So you're not relying on just, the cable pulling out through the slot here. So there'll be 2 full wraps left, and when it's all the way up, the cable's going to be all the way to this last groove on this side. So what we want to do is this last groove, we want that to be in line with the, we want this last groove to be in line with the hole that we put where the cable's going to mount on the elevator itself. That way when it comes all the way up, when the cable's at shortest, you want that straight. When it starts stretching out and it's going from here to the floor, the cable might be slightly tilted, but it's such a long distance that it's not a big deal. You don't want to have the cable, the end of the cable here, and have it to the outside of the pulley here, or way off like this, because then the cable in a 6-inch span is going to be on a pretty tight angle. You want it when it's all the way up to be as lined up with the last groove as possible. So now that we got the shaft itself centered, every one of these pillow block bearings has set screws in it that lock the shaft to the bearing. So I'm just going to snug those down. Since the center bearing is screwed in tight right now, the shaft won't be able to walk sideways anymore. So now it's locked in place right to left. So the idea is I want 2 bearings, one on each side of these drums, because this is where all the weight is on these drums right here. So I don't want that shaft to deflect and torque and twist that shaft. If it's right between two pillow block bearings like this, that shaft is extremely strong. And this is solid 1-inch round bar shaft with a 1/4-inch keyway in it. So once we get everything how we want it, we got to put the keys in the shaft to lock these into place too, because these are keyed as well. This 1/4 by 1/4 keyway shaft material. So the keyway on this drum is 3.5 inches long. And then we can slide this over the keyway, and now it's locked onto that shaft. And we do have a series of set screws here that will make it tight on the shaft so it doesn't wobble or anything. But the keyway is what does the locating, allows it not to slip. So these ones I'm using a larger washer on the back side because it's wood back there. But I'm also putting a lock washer on it too, so we'll crank this down real good afterwards, and it should lock everything in place and don't have to worry about it vibrating loose or anything like that. Okay, not sure how well you guys can see on camera, but so I got the laser, I got the keyway turned, so it's kind of like in the center of the keyway. And it's pretty good, and I get to the end here, the shaft's a little low. So I'm gonna try pushing this side up. And I don't know if I can bring the center down a little bit too. I don't know how much play I got. But I'll just kind of shift these up and down until I get it lined up good. And this gear right now is just loose. Eventually I had to get a keyway in it and the set screws in it. But until we get the motor mounted and lined up with it, we're gonna leave that loose. Same thing with this pulley here. We're gonna leave that loose until we get the rotary limit switch mounted, figure out where that's gonna be. And then there's a set of set screws that go through that and lock that in place. There's no keyway on this, but there's so little load on it, it's not gonna slip. But it feels really good. It turns, doesn't bind. Nothing's rubbing. We got enough room for the chain here. I think we're pretty good. So it's been a couple days. I was waiting on some parts and a couple components here. I want to show you guys what we're actually using for the hoist motor to power this whole contraption we got going on here. So what I got here is a V-bore 2,200 pound overhead hoist, it's 110 volts. It comes with a wireless remote. And what we're gonna do, so it's a 2,200 pound hoist if it's in like the double line setup where you hook the hook back up to itself and you have like a block and pulley on the part you're lifting. So it makes it twice as slow, but twice as powerful in lifting application. So what I did was I already unbolted the motor from the bottom of this plate. It's just 4 bolts in the bottom. And you can basically just slide this motor out of this housing. And we are still going to use this housing here in a minute. I'll show you. And then once you do that, there's a bearing on the end, like a support bearing. And then this drum just slides right off the shaft. And the shaft on the actual motor is a hex shaft. What I want to do here is I want to have a gear on this because I'm just basically using this motor and the gear reduction that's built into it and the brake system that's built into it to power this, and the brake to hold the load once the elevator is up or down or anywhere it's at. The brake in here, mechanical brake, will keep it where it's supposed to be. So this is designed to where, you know, if it's made to pick up 1,100 pounds straight up, then it's designed to hold 1,100 pounds from coming back down as well once you let off the button, which is important. Basically, I got it plugged in, and all you gotta do to operate it is a start button, and then you got up and down. Real simple. So in the effort to make this kind of as safe as possible and make it so it just works when I want to use it, what I did was did some simple math on this whole thing. The output speed of this shaft is 44 RPM is what I came up with. The elevator itself, I didn't want it painfully slow and I didn't want it crazy fast. I figured, you know, within 30 seconds I think is a good time to travel 13 feet. And that's kind of the number that I shot for. Basically, I'm reducing the motor 2 to 1. So I got an 18 tooth gear that goes on the motor here, and it's a 36 tooth gear up on the shaft. So now the shaft speed up there when this motor's running is 22 RPM instead of 44 RPM. The drums on the ends of the shafts are 6-inch diameter drums, cable drums. So every one rotation of that drum, the cable travels about 18 inches of lift. So with that being said, to go the 13 feet, it's got to do about 9 revolutions, and it'll be all the way at the full height. It comes out to about 26 seconds or so from the floor to full height. So that was the first kind of math problem to figure that part out. And then what else there was making sure that the motor torque was still strong enough to do what I wanted it to do. And by reducing the 2 to 1, then obviously it doubles the torque of the motor output. It cuts the speed in half, but doubles the torque. But now my drum size is up there, the 6-inch drums, is about 40% larger than the factory cable drum that was on this hoist. The factory drum, the center of it was a little over 3 inches, but then the cables, as they went on top of each other, you know, basically the drum size gets larger. So the more cable on the drum, the actually less power you have with a hoist like this, where the cable stacks on top of itself. That's why if you ever get a winch on your pickup truck or a four-wheeler, when they give you a weight rating capacity, pull capacity, it's usually when it's the last wrap or the first wrap on the drum of the winch. So when it's all bound up on there and you got, you know, 5 layers thick of cable or the synthetic rope on your winch, your capacity actually decreases quite a bit as it stacks up. But when you're on that smaller drum in the center, that's where you actually get your true capacity at. So long story short, you know, we doubled the capacity here, but then we basically increased the size of the drums. With a little bit of math, it comes out to, instead of 1,100 pounds of capacity, if that's like what the max of this actually was, it's actually 1,200 pounds with the way the math works out. And not that I'm trying to pick up 1,200 pounds, but I just wanted to make sure that I was still within spec of at least what this hoist was. That number also, with the figuring out the torque capacity of it, also tells me the braking capacity of it. So if that number would have came in at 400 pounds, you know, that means the motor itself may only be able to pick up 400 pounds and it'd probably be overloaded trying to do it. But then the braking capacity would get cut down, because when you do gear reduction like we did on the motor, you actually are doubling the braking capacity. But when you put the larger drums on it, it does the complete opposite. Now you have a larger lever basically for the cable to turn that shaft and to fight the brake inside the motor. Long story short, braking capacity basically goes up like 8 to 10%, just like the lift capacity did. It's almost the same formula. So all that plays out good. All that math worked out well. So the other thing the other huge portion of it, and like we talked upstairs when I put that smaller aluminum pulley on the shaft up there, was for the limit switch. And I was kicking around trying to figure out how I'm going to actually put some limit switches in this thing, so when it gets down to the floor right before the cables begin to slack, I want it to stop. And I also don't want it to go up too high and hit the top of the track and have no place for it to go, and then the motor's putting way more strain on the cables or lift than it should. First I was thinking about, some little micro switches up high and low, and it would hit them on the trolleys or the track as it's going down. Then I have to have wiring going up and down, and if the switches got bent or broke, it wouldn't be a great scenario, I didn't think. So with a little bit of searching, what I found was LiftMaster makes a limit switch box, and what this is typically used for is like motor operated gates, like a gate across a parking lot that travels and has a chain drive. And this unit here has a gear on the end, and it's a rotary switch, or it's a rotary limit switch, basically they call it. And what it does inside is as you turn this gear, those little gray blocks there will travel, and you can set the location of those blocks by depressing this little lever here, and you can move them back and forth. And what they do is they click these little micro switches on both sides, and we can wire those into the hoist, and it's measuring the shaft up there. As the shaft's spinning, it's going to spin this shaft here. We're going to take that gear off, and we're going to put on timing pulley, and we're going to use the belt like we have up there. I have 2 of them. It came with 2 when I ordered it. That'll connect on there. This will hook on the shaft. So as that shaft spins, it's going to spin this limit switch box, and we'll be able to set the upper and lower switches on this and have it be able to stop right where we want it to stop. This comes with a limit switch kind of built into it, and all this does is when the cable's coming up through here, it's got a stopper on it. It hits that, it depresses a little micro switch inside this box. It just doesn't allow it to go up any higher. There's no down limit to it. But when it depresses that switch, all you're allowed to do at that point is hit the down button. The up button no longer does anything. And that's the exact same way we're going to set up these switches. Once it hits the upper switch, the up button won't do anything anymore. You'll only be able to hit the down, and the same thing at the bottom. When it hits the lower limit, you're not going to be able to hit down anymore. You're only going to be able to hit up. So should work well. So this will get removed. This little box here will tap into the wiring, and I think that's going to work really well. So we're still going to use that. We're going to just basically put it back into the housing with the bearing on here. This bearing sits inside the recess here of the housing. But what we're going to do, instead of putting the cable drum back on, is we're going to put our 18-tooth gear. So I couldn't find, and I pretty much knew they don't make a hex shaft center bore for like gears and things like that. These are weld-on hubs. So this is a W hub, which I believe has like 1.5 inch bore here for your gears. They make an X hub that's a little larger, maybe 2 inches, the center hole of the gear would be. So they make a bunch of these with all different bore sizes, and then you buy the corresponding gear that fits onto these. So you can, you could buy a 30-tooth gear that fits on here, an 18-tooth, 10-tooth, whatever you wanted that fits onto these hubs, and you can find hubs that fit the shaft you need. So what I found was an 1 3/16 center bore ID hub fits basically perfectly, it's a little snug, right onto this shaft here. So the high points of the shaft is basically an 1 3/16. And then what I can do is I can tighten down these set screws onto the flats of the shaft here, and then at a center it'll be located right where I want it, and then I'll just stitch it on. I'll weld it on with a few stitches, kind of maybe on each flat or every other one. We're going to be in great shape. So basically that end up on there, we'll probably locate it somewhere in the center. That will fit back in here. So okay, so you can see I got it through bolted into the strut there. These are bolted into the unistrut nuts into the strut there. And what that allows to do is either I can loosen these, which might be easier than trying to get to these behind the motor once it's in there, and I'll be able to lift this up. But that allowed me to tension the chain. So I'll get the chain cut to length as close as I can, and then we'll get it tight by slightly scooting this up and then torquing down the bolts out here. We'll get the gear welded on, and I probably have to cut a hole through this plate where the chain can pass through and get to the gear here and it'll come over. A small amount of pressure to hold it down. I'll probably stitch these two sides here, and that's all we're going to need. I have a mark here on the shaft already. That's where it'll slide onto. And what I'll do is I'll wet down this rag and I will keep it up against the motor here. And what that will do is help keep the heat from traveling into the motor, because I don't want to melt the seal or anything that's on the outside of this motor here. All right, we got it at the mark. We're going to use the set screws to lock it down to the flats on the shaft. Okay, we've got our wet rag here up against the motor. And one other very important thing, anytime you're welding anything that may have bearings, ball bearings, needle bearings, anything like that, it's very important to put your ground, in this case, on the shaft that we're welding. If I just left it on the table, that means the current's going to travel through the housing of this motor. It's going to have to go through the gears, through the ball bearings, everything to get to this shaft to complete the circuit. And what happens is when that current jumps across the little ball bearings in there, it arcs them out, and then they end up getting burnt, and sometimes they'll seize, they'll weld themselves together. So you never want to have your current having to take the long path through a bearing set, a gear set, a motor, anything like that. Anytime you can hook to the shaft or the gear itself you're welding, that's the best case, because the current's going to go right from where I'm welding to here, and it's never even going to be traveling through this section of the motor housing. That's it, pretty simple. So we're just going to let that cool. I'm going to leave this rag here so it helps pull the heat out of there, let it cool completely. Then we'll take it back up and put it in place. I had to make this contraption. I had a piece of rod zip tied and taped to a wrench. I've been fighting these bolts for about 30 minutes trying to get them tight, but this allows me to reach them from the bottom here. So this is like number 40 chain, probably much more than we really need, but like I said before, I'd rather have it stronger than not strong enough. That looks pretty good right there. Mark where I gotta cut it. So that's what you want to end up with, is two of the narrow links on each end. With the master link, you take the little retaining clip off, slides off, and then you can pass these through your two links, like so. Makes your connection. And then you gotta make sure you put the dog bone on this side, because this is what actually holds the weight. The little clip can't actually hold any weight. That just keeps the bone from coming off. You put it on there, and you take a little screwdriver and click it in, and it makes your connection. So you can make your chain whatever length you want. Screwdriver. That's it. So now you can see it's pretty loose. It's amazing what like one extra link can do as far as making a chain loose. So we're going to push this motor up now and get this nice and tight. You don't want it crazy tight, because you don't want to put a bunch of unnecessary strain on, the shaft or the bearings or anything like that. But, about a ½ inch of play is about all you want if you push it on the chain. All right, moment of truth. So, sorry it's a little dark. One of my lights went out, but got all the set screws in, gears in, motor's tight, chain is tight. Everything is in line. We have the motor controller. I just got it stuffed up there right now. I'm going to get it actually secured in a minute. I just got it plugged in a cord. So let's start. And show you guys how to put one of these ends on the cable here. So this is like a termination end that's got a screw on it. And these are designed for overhead lifting. So whatever the capacity of the cable is, these are designed to hold the same amount. A little tricky. I never done one before, so I just kind of figured it out on that one. Important thing is having a good clean cut on the end. So anytime you cut cable like this, it's a good idea to tape up the end of it. I had some foil tape here, and then you got to go ahead and cut it with a cutoff wheel. Pretty good cut. A couple that opened up, but it should be okay. And we remove the end like that. This is the end we got to put in the vise, and you need this little brass cone thing. So you're gonna take this end, the short end, and get it onto the cable. Kind of twist it as you go on there to help align the strands up, and then you can get it on like that. So once you got it in there, you put it in a vise. And you want it pretty solid to where you can tap on it, but you don't want to be, cranking it and deforming that thing. So now we got to open up these strands, and you don't want to fray it. You just want to get the individual strands that are made up of a bunch of the little wires in there. So you want to try to keep them so they're not all frayed, but you just want to open up each one of these about 2 wraps off of the center core here. So these things are a little tricky, and I feel like if you had a larger cable, it'd probably be easier. So this has a center wire core in it. So the center cable is twisted slightly different than the other ones, but it does have a center cord in it that all the other ones are around. So once you get it kind of opened up, you just want to arrange them so that the core is still in the center. You take your core, and this little cone has a hole in the center of it, and from the pointed end, you're going to feed your core through there. And same thing, you got to kind of twist it the same direction the cable's twisted, so this is counterclockwise, and slide it down over that core so it's sticking up just slightly. So you want to work these so that that's in the center. Put it down in here to help kind of hold the base together. We want to arrange these so that they're all kind of equally around this center cone. So that's how it should look. That's how it should look once it's where it's supposed to be. So once you have that, then we got to drive this cone down into the receiver here. And you need something hollow so that the core can come up through and that cone goes down, because the cable shouldn't go down anymore, but the core should, or the cone should. So the core needs to stay up. So I got like a 5mm socket here, a real small deep well socket. I'm gonna put it over top of that cone. Make sure we're not hitting any of the strands. Make sure they're still spaced evenly. I'm just gonna gently drive it down in there. So it says you should get it about 2/3 of the way in, and at least 2/3 of the way in. If you get a little more than that, it's not a problem. It's just that's what's actually locking it in there. So all the stress when this gets pulled down there, it's trying to pull that brass cone with it, and these are past it, so these are folding over, and it's driving it into the walls of this sleeve here, and that's what gives you the pull-out strength. So once you get that kind of position, it says to try to bend the strands around the top of this cone so you can get it into here. But I feel like these wires, they have too much spring to them, so unless you're gonna like really overbend them, I don't know how you're supposed to do that. So all I did was I just put them on here, and I just kind of work this in and just rotate it a little bit and kind of use the threads to help guide them in. So once you get them in there, you kind of use the threads to help guide them in. Get it to start down on that thread. And this, it just says go until it's tight. It doesn't have like a torque rating. It just says crank it down until it's tight. We're going to lock this fitting in the vise a little better. So that's good tight there. And then what it says to do is there's a little tiny hole in the end of that fitting right there. I don't know if you guys can see it. Little hole right there. You should be able to look into that hole and see the ends of the strands. If you don't see them, then it means you didn't have enough wire far enough up inside here. But looking in there, I can see the wires inside there. So that means this is far enough up in here, and this is tight. Everything's locked in. The harder you pull on this, the harder it bites into that cone, and it wedges itself into that end here, giving you a solid connection. So pretty slick. The first one I did took me, probably almost 25 minutes to do it because I didn't really know what I was doing. This one didn't take too long, but I think that looks pretty good. So what we're gonna do now is just line up these two ends, and then I'm gonna cut it in the center down there, and then we'll figure out how we're gonna wind it up on the drums up there and figure out our lengths. So I just made up a couple of these tabs out of some 2-inch tubing, 3/16 wall, and you see I just welded this one on here. This is gonna be where the cable attachment point's gonna be. Originally I was thinking of connecting it up on this top rail, but when the cable gets all the way up close to the drum up there, it's gonna be a little bit of an angle, the cable, and I don't wanna have it stressing on these studs as it comes up. So if I connect it lower, even when the cable's all the way up, it's still gonna have like 3 feet of cable from the drum to here. Actually more than that, almost like 42 inches. So even if the cable is not perfectly lined up, it's not so out of alignment right at the drum. So I just welded that one on. I'm gonna go put this one on the other side, and then I think we're gonna wind the cable up on the drums and try hooking it up. So we're gonna get these cables attached. I'm gonna leave about an inch adjustment above it, and it's got about 2.5 inches below it on each side. And I'm gonna put a nut on the top and a washer, and then a washer and nut on the bottom. So I think if I keep at least 3 full wraps on here, I'll still be able to have enough upwards travel and have at least 1 extra wrap than what's required. Okay, so if that's right, I have basically 3.5 full wraps left on the drum with it all the way down. How I'm going to terminate this end, we're going to end up using a cable clamp. So you got your saddle and your U-bolt. And I'm sure most of you have heard of never saddling a dead horse. And all that means is when you put on a cable clamp, you make a loop. The end that's your dead end, the end that's cut, that's not the working load side, is the side that you put the U-bolt on. And the working part of the cable is where the saddle goes. So you don't want the saddle on the dead horse, the dead end. You want the saddle on the live load end. And then your U-bolt goes, oh, there goes our U-bolt. Your U-bolt goes on top of the dead end there. There really is no load on the end of this cable here. But you also don't want to have it where it could pop out of this little notch here, or if something was to happen, it was a slip, at least there is a positive connection there actually holding it. So we're gonna make sure these are in there, go around there. You just want to tighten them up even. So I do need to cut the excess off. Moment of truth. I'm just gonna see if it starts to wrap okay, and then I'll go down there and we'll go up and down a little bit and see how it's operating and see if it's level. Okay, seems to be working. Cables are staying in their grooves. Let's go down below and take a look at it. Before we go any further, I just want to make sure it's at least close to level. If it's not, we can adjust it. It's pretty darn good. The right side's, or left side's a little high. I'll loosen this side up a touch. Let's see what happens here. Go down a little bit first. Okay, it's all the way down. Oh, my laser just got squished. Forgot that was there. We're not going to be able to go all the way up, obviously, because there are temporary platforms up there. We can go up a little higher, though. That was pretty smooth. Speed looks good. Looks like it's staying level. But the drums are winding up really good. Let's come back down. Guess we'll see if it picks me up. I'll go up a foot or so. Oh yeah. I think it's even smoother with some weight on it. That's beautiful. One thing I want to check is when it gets loaded out of balance. I'm going to stand in this corner here and see what happens when we go up. Oh yeah. Smooth as can be. So very good. Super happy. But I gotta go out to dinner with the family, so I'm gonna call it a night, and we'll see you guys probably tomorrow morning. So it's been a few days, and I haven't had a ton of time to work on the lift here, but I was messing with it the other day and testing it, and I did discover a little issue that I have, and I'm gonna see if I can get that at least fixed today. So let me show you what's kind of going on here. So I set the laser back up. It's just hanging on a piece of tube there, shining across the shaft here. And it might be a little difficult for you guys to see. I have to hold my hand. So if you see, I have the laser basically right at the very bottom of the shaft. So like you can't see the laser getting past the shaft there. And same thing is going on this side. You can't really, the laser's really not getting past the shaft. It's right at the very bottom. But you come to the center, and what happened is this center shaft has moved up. This bearing block has scooted up, I'd say at least a 1/4 inch, maybe even a little more than that. And what that did was, this side of the chain is solid because the motor's pulling in this direction and rotating. And this side is pretty darn loose. It's like actually coming off the gear a little bit. So when I bought all the parts, I got 6 bearing blocks. I put 2 on each end on either side of the cable drums, and I was going to put 2 in the center on either side of the gear. When I was putting it all up there, I don't know what made me decide, but I'm like, the center only needs 1. It's just the gear on there. I wasn't really thinking on the load that is applied to that gear, whether the weight that it's holding while the brake is on or as the motor is rotating and has to pull up on that side of the gear. That amount of force is lifting on that shaft there. So I did. Originally, if you guys remember when I put that on, I had just like those 5-inch or 6-inch like header lock screws going into there. I did switch those out to like an 8-inch, 1/2-inch lag bolt, and those go all the way through into there's an LVL behind here, like a chunk of it that comes down from the one above. So they're fully threaded, but the holes in the bearing blocks are slotted for adjustment. So you do have a slot in there, so there's enough movement that you can move. So I think what's happening is there's just not enough torque on those bolts, and being that I have the 2-inch spacer steel behind them to lock it down tight enough and not get that movement in those slotted holes. I'm going to add another one, since I have it, to the other side of the gear, to the right side of it, kind of equal distance to the other side of the gear. What I'm going to end up doing is I'll probably lower the lift all the way down. I'll unbolt that one by the cable drum there. I'll slide that one all the way over. I'll make a new spacer block there, and then I'll have to take the end off, slip the cable drum off, and slide a new one on and put it back together. So I think the one that I can put here on this side, of the shaft, I can get behind this LVL. So I'll be able to through bolt it, kind of like how I did all these other ones. They're through bolted, and none of those have moved yet, being through bolted. It's just the one that's lagged in. I just don't think I can get enough clamping force with the lag screw like I can with a nut, bolt, and washer. So I think if I add a second one, through bolted, nut, bolt, and washer, bring this back down where it goes, I think it's going to solve our problem. So I think another problem I'm having too is I don't have the limit switches wired in or anything yet. I just mounted the box up here. This was tight, but when this shifted, it kind of loosened up. Since this shaft only rotates about 11 rotations from full up to full down, I'm not getting a ton of travel out of these stops as this is spinning. These little wheels move right and left, and they click these limit switches on either side. And I didn't wire them in yet, but what I'm noticing is I'm not getting very much travel, so they're not as sensitive. Like, it's taking them too long to trip the switch. And even though the switch almost trips always in the same amount of time or the same position, when it's such a small amount of travel, it doesn't really shut the switch off quick enough. So the solution to that is this is a 26 tooth gear pulley on here, and it's like a 15 or 12 on the limit switch here. I just ordered a 40 tooth, so it'll be much larger, which is gonna basically double the speed almost of the shaft here, which I still have enough. I counted the rotations, I still have plenty of travel. I think that's gonna help out with tripping those switches a little crisper or quicker and shutting it off where I need it to. Okay, so I added the second bearing block. Like I said earlier, I ended up sliding that one down, pulled the spool off, added another bearing block, and then added one to the outside. So now we got 6 all together on here. I feel much more comfortable now. This is actually through bolted, nutted, and washer and nut on the back. So plenty of clamping force now. It shouldn't move. The chain is staying nice and tight front and back. Hey guys, so I got the limit switch mounted up here, and I got the new updated pulley size. So now I got a 40 tooth pulley here on the shaft. I need to get 4 wires from here up to the hoist control. So I had some 4-wire cord here. So we're just going to use 2 sets of these for each switch. I got it ran up here, and I just opened up the control box for the actual hoist. So what I'm going to do is I'll hit down here. I don't know if you noticed, but that contactor is what just went in. So you can do it manually too. If I was to push this, that'd go down, and that'd go up. So these are just basically electronically controlled heavy-duty switches. So you have your power coming in, and your power going out to the motor, and then you have a low voltage or less amperage trigger switch that applies the current to activate it. So that's what we want to interrupt. We don't want to interrupt the power going to the motor, because that has a heavier load on it. And I don't want that heavy load going through those small micro switches, even though they're good for, I think, 12 amps a piece. It probably would be fine, but the safer route is we'll find the wires that are triggering these, and those have just milliamps going to them, less than an amp. And that's the wire that we'll have actually disconnected by the switch. So let me show you guys how I ended up hooking this up. My camera cut out when I was doing it, and I thought I got recorded, but I'll show you after the fact here. So this little control board here is what sends a signal when you hit the wireless remote controls. And the 2 yellows coming in is your hot and your neutral from the power from the plug that's actually plugged in. It comes into the unit. So you got your line 1 and line 2 here. So those are the incoming power, and then these are the red and black was what was going out. So the red and black used to go to these red and black, and one of them went to the down contactor, and one of them went to the up contactor. So this black wire used to be hooked to this black wire, and this red wire used to be hooked to this red wire. So all I did was cut those, separated them, and the red wire came out. I sent it down the red wire to the limit switch to one side of the switch. I used the white wire coming back to here and reconnected it back to the red wire. So all I did was interrupt that wire. They used to be connected together. All I did was interrupt it with the limit switch on there. So that was the up limit switch. Same thing with the black one. The black one used to be connected there. I sent it to the limit switch, for the down limit switch, sent it back. It came back on the green wire and connected back to itself. So again, all that did over there was just interrupt this connection. So when I hit the down remote or up remote, the signal that used to come from here, the low amperage trigger wire that used to control these contactors, gets interrupted by those limit switches in there now. So it's just a very simple splice. So I just used some heat shrink solder connectors here. So we're gonna test this real quick. So this one is the down. So if I hit down, see how it stops it? Even if I'm hitting the button, but it still allows me to go up. So even if it goes all the way down and trips it, I still can go back up until it stops. So now we got the up. Lets us go down, doesn't let us go up. So, okay, we know it works. We can put the cover back on, and we'll see if we can get the limit switches set. Okay, we got the bottom limit set now. Stops perfect. Doesn't let me go down. Allows me to go back up. Repeats it every time. So I went ahead and made a little automatic latch. I just cut a piece of stock and a notch in it, and I got a bolt just welded on the side here. So now when you pick this thing up, it just latches right in place. And you want to take it down, lift it up. Oh. And it kind of works nice because as the chain is hanging, it lifts this up slightly, and as you bring it in, the weight of the chain actually holds it down and pulls it back, you know, where this is straight up and down. So I feel like it works pretty good. All right, I got it all disassembled. I'm just gonna go ahead and weld all the back sides of these that I couldn't get to while I kind of built it in place on the wall there, and get it wiped down. Make sure there's no welding spatter on it, then get it painted up. I'm just using some of this tractor paint from, I think it's Family Farm and Home. It's pretty good stuff actually, but I'm not gonna worry about priming that or anything. This stuff covers really well, and since it's always indoors, it's climate controlled, I'm not worried about it rusting. I just want to cover it up and make it look good. So we're just gonna put a couple coats of this on and call it good. So if you ever got to stir up a small quart of paint like this and you don't have a stirring stick, you just take an old Allen wrench, chuck it in your drill, spin it, when you're done you wipe it off. There's some pretty thick stuff at the bottom of this paint I got to mix up. Comes clean when you're done. We're gonna get this thing put back together now that it's painted. Once I get bolted up, there's a few touch-ups I gotta do, just where it was sitting on the horses, but other than that, it should be good to go. So let's get all bolted up and the last time taking it apart. All right, so pretty much the last thing to do is, this is just a piece of 1/2-inch OSB I had it kind of on here temporary, and I got a piece of 3/4 subfloor. It's a lot denser of an OSB than your traditional, 1/2-inch OSB type stuff. And it's 3/4 thick, so it'll help stiffen up the floor a little bit there. So I'm gonna pull this one off. I already pulled the screws out. Get that one cut to size, get it screwed in, and we're pretty much done at that point. So let's get to it. So I didn't have any like self-tapping screws that would have been the right length. So I got some 2-inch like construction screws. I pre-drilled them. They should be able to bite in the steel. Yeah, those work good. So the trick is if you want to try to put a screw like this into steel, you got to get a bit to pre-drill them. And if you line the bit up, you want just the slightest bit of threads larger than the bit. So as long as just the threads are larger than the bit, they'll bite into the steel and actually grab. If you try to go too small, they'll snap off in there. If you go too big, it won't grab. But if you get it just right, you can put this style wood screw through wood into steel, and it will grab. We don't need a ton of them in here. I'm only gonna put like 1 every 2 feet around the perimeter, and maybe 2 in the center. All right, one last thing is I see myself using this as a workbench. Not necessarily for pounding things on or building anything out of steel or anything like that, but if I'm assembling something or if I have parts laid out, if I'm working on something, I see myself using this as a table. I can bring it up to the height I want. If I gotta put something together, tinker on something, I want them on here. So I had this roll of like indoor-outdoor carpet. I put that on there. It's gonna make a nice soft workbench. It's also gonna be nice for sliding the bins and things on. That's gonna go up to the top. So I'm gonna go ahead and put this on and see how it looks. And just for fun, we're gonna put some of this black and yellow safety tape on here. Just so if I have it up high or, you know, walk into it or something like that. Not that I think anybody would, but it makes it look official. Anytime you're applying any type of tape like this, even masking tape when you're taping off a wall or something like that, you never want to overstretch tape. Like you can stretch it to get it to unroll, but you want it to relax when you put it on there. If you overstretch it and put all that tension into it, once you apply it and stick it, it tries to contract on itself. Plus, the tape won't go on as straight when you stretch it. When you stretch it, it ends up actually curving the tape slightly. You stretch it out, or unroll it, let it relax, and then set it down. Don't keep pulling tight on it. You'll get some wavy lines. All right, guys, what do you think? I think it looks pretty good. Looks official. I bought this carpet a while back, and I didn't buy it for this project, but it says it's 6 foot by 8 foot, and this platform's like 94.5 inches wide, and you can see the carpet's a little short, so they ripped me off. So yeah, this is a great work surface now, so I think it looks good. Guys, one last thing we need to do is we need to load test this thing. So I have 18 of these tractor weights. They're 42 pounds a piece. I don't know if you can read it there. So if my math's right, 18 of them, 42 pounds, should be 756 pounds of weight we're gonna put on here. I'm never probably gonna be even half of that when I use this thing on a regular basis, maybe 300 pounds at a time. It just makes me feel good knowing that it can do the 750 without an issue. So that way, when I do use it on a regular basis, I don't have to worry about it. So I'm gonna drop it to the floor, load them up, and we'll see how it goes. 10, 12, 14, 16, 18, 42-pound weights. And we're gonna see what happens. So this is 750 pounds, 756 pounds to be exact. We'll see how she does. Seems to be no problem. Just gonna hold it and let the limit switch stop it. Hopefully it stops where it's supposed to. She stopped. Come on down. Seems pretty effortless. Just gonna keep holding it, let the limit switch stop it. I'm sure it's gonna touch, see, because it's sagging slightly. Perfect. There was just a slight bow to the front here. Maybe, I mean, I could put a level on it and check, but it might be drooping maybe a ½ inch or so. But I'd say that's pretty effortless. So that makes me happy. I could probably put more on it. I don't think it's necessary. A little reassurance knowing that it can handle this type of weight. So when I'm doing much less, it's a lot safer. Think I should go on it with the weight. So, just for fun, we were at 750 and I'm about 185. So we'll be at 930. I'm not gonna go all the way up because I don't feel like dying if it does fall. I'll go up a little bit here. No problem. So, almost 1,000 pounds. Doesn't even seem to be straining or whining. So I would call that a success. Got everything painted up. We got our little caution tape on the front. I even did a little safety tie wire on the shackles here, so that way these pins can't accidentally back out when I'm not paying attention. Everything's got lock washers and lock nuts, or lock washers on them and washers. Everything's torqued down good. I think all in all, looks really good. Here's a little closer look at that. The latch here that grabs onto the pin. I'll fold it up here in a minute for you guys so you can see it. I ended up painting the tracks all the way up. I wasn't fond on how it looked with just touch-up paint when I welded those brackets on there, so I painted them black. I didn't paint the insides. That way the rollers, the bearings aren't trying to rub on, you know, paint in there and having the paint wear off. I just painted the outside of them and painted the brackets. So, all in all, I think it looks really good. You got the little nylon bushings in between the two, so it pivots nice and smooth. I was gonna add a spring system to help lift it up, but it's not, it pivots super nice. So I don't think I'm gonna mess with that. So when it's not being used, it just folds up like so, locks in place, and then what I can do is I can park it up out of the way like that. So now it doesn't take up any floor space, doesn't block either of my windows, and just looks nice and neat. And if I need it, I can drop it down. And actually another benefit, in the summertime, sometimes I do get a pretty direct line of sunlight through that top window. And you know, if I'm on the computer or something, it can add some glare. So I can actually use this as my shade and block the window if I needed to. So just one more thing I can do with it. Guys, thanks so much for watching. I hope you guys appreciated this project as much as I did. I did put a lot of thought into this project, and surprisingly, a lot of hours. It took much longer than I thought, but you know, only working a few hours each day and a little bit on the weekends, you know, everything takes longer. But I'm extremely happy on how it turned out. There's not a whole lot much different I would do if I had to do it again. Everything works pretty much just like I planned it to. Even the time from the floor to the top, you know, it's right around 28 seconds, and like that was the number I was shooting for, was between 25 and 30 seconds, so it was like spot on. I'm just overall super pleased with it. This is gonna be a huge, huge improvement to the shop. Just being able to to put long-term storage stuff away and to get better organized. So one other thing we're probably gonna do is I'll probably put a quick video together after this, maybe a short, of kind of a breakdown of all the parts and pieces and give you a total cost of what this project ended up costing in the end. There was a few things that I bought and rebought because they weren't exactly what I wanted, but now that I knew everything that I used, I can put a whole list together for you and give you an exact price of what this project costs. So
How do you know?
I'm gonna add it up. How do you know? You don't? So if you guys got any questions or comments, suggestions, something you think I should do or should have done differently, let me know, leave a comment. Don't be afraid to ask. Tommy got some stitches last week.
Yeah.
You wanna tell him what happened?
That's the one that tripped on a chair and hit my back on a metal chair.
How'd the chair look? Better than you?
No worse.
It looked worse?
Yeah.
Oh, jeez.
There's a dent in the chair.
You dented the chair with your head?
Yeah.
Oh, my goodness.
That's how it's split it open.
Man.
It's only like this big.
So Tommy got 5 stitches. I think they come out tomorrow, right? Again, thanks for watching, and I'll see you on the next one.
Thank you for watching, and like and subscribe, please.
See ya.
Goodbye. Hello.